So let's talk about another important aspect to do with the circulation in the ocean. It's something we call biological connectivity. It relates to the oceanic transport of passive larvae. If you have larvae, fish larvae, what's the connectivity between two locations? One location A, one location B. Are they connected in terms of larvae transport or not? Are they too far away from each other? It's not that difficult if you have currents which are the same all the time. If you have a steady state East Australian current, it becomes substantially more complex if you actually have seasonal variations of the circulation. And I just want to illustrate that with this example that I just sketched here on the left side. So just imagine you are in an oceanic region, in a basin where you have seasonal variations of the circulation. Okay, so from January to June, you actually have two gyres established here. And in the northern part of the region, you have a clockwise gyre. And in the southern part, you have an anti-clockwise gyre, and you actually have a flow from east to west in the center. In addition to that, you have a flow shadow, a region of little flow here in the northeastern corner. However, in the other season, other time of the year, from June to December, you have the situation where one large gyre develops and you have a zone of little flow in the center, flow shadow. Okay, so this can happen on larger scales in the ocean. So if you think, you'll learn later on from the Indian Ocean, there are significant seasonal variations, but you can also have seasonal variations on smaller scales. Seasonal variations like in Spencer Gulf. It's not the same as shown here, but anyway, there's seasonal variation. So now let's just imagine what happens to a larvae, fish larvae that's somewhere located here. Now here, for example, we can do one example where just imagine you are in the southern part of the basin, okay, and you have very, very small flows, so you essentially move from east to west, okay. Can you see where the mouse is down there? Look where my finger is. This is where the mouse is, okay. And now I move over and move over. So this is where you start, and you drift from east to west, okay, from June to December. Then you are in January to June. I jump over to the other season here, and you move back from west to east. So all that happens over the year is you just move from left to right and back. Okay? That's one example. Okay, but what also could happen is, alternatively, is you move actually from June to December all the way along this big gyre over the top northeastern corner. You end up in the flow shadow and you become trapped there for 6 months. No flow, little flow in the trapping zone. And then you go back to June to December, and then you might move around. Or you become subject to this central flow from east to west, and you become trapped in this flow shadow inside this zone. So you can see, you can use this example to actually illustrate there is a great variety of different situations, very complex features if you think of the trajectories, the flow path of objects in the ocean or fish larvae. Okay? So this is another feature associated to the currents, although they are very robust patterns here that repeat all the time. The drift patterns of objects can be very, very complex. All right.